So this is the video on formula equations and word equations. We use symbols when we write chemical equations. So what do those symbols mean? And what are those symbols and what are the reaction conditions and how do we use them? This is actually a chart that summarizes all of them. Whenever you see that substances have a solid, liquid or gaseous state, you are going to see S, L or G in parentheses. When the substance is dissolved in water, you're going to see AQ in parentheses, and this arrow in the middle, this is read as yield or to produce or to give. This arrow in the middle separates the reactants from the products. Reactants on the left side, products on the right side, which actually indicates the result of a reaction. When the reactants are heated, you're going to indicate by placing this little triangle, which is actually a Greek letter delta, right above the arrow. When the catalysts are used to speed up the reactions, that catalyst is shown by putting right above the arrow. And when the reaction proceeds both ways, the backward and the forward and the backward, you put double arrow. That shows that it is a reversible reaction. So at the end, when the reaction is there at the end, the final resultant will be the mixture of reactants and products. All of them will be there since the reaction is proceeding both ways, left and right. Plus sign right here, like this plus sign and this plus sign, you can read it as and or you can read it as plus. On the reactant side, you will read it, you're going to say this A reacts with BC, or you can say A combines with BC. Whenever there is a specific temperature, you tell that by writing the temperature right above an arrow. And sometimes the substances don't react with each other. At that time, you write NR on the product side, which shows that there is no reaction. So here methane gas reacts with oxygen gas to yield carbon dioxide gas and liquid waters. So how are you going to work on this? Is the most important thing is you figure out which is the reactant and which is the product. So methane gas is reacting with oxygen gas. So this is your reactant. It says this and this, two things are reacting. So methane gas is reacting with oxygen gas, okay, and it says to yield. Yield means an arrow, which is right here. What is it yielding? What is it producing? Carbon dioxide gas and liquid water. So that goes on the right side because they are the product. And please write down liquid, gas, gas and gas. Formula equations, meaning now you're going to write the formula for each of them. Methane is CH4 and it says gas, you write G in parentheses. Then it says oxygen, O2, G in parentheses, and carbon dioxide gas is CO2, G in parentheses, and liquid water, so water is H2O and L in parentheses to show the physical state, liquid. Now here, why am I writing this 2 at the bottom of oxygen? Because this belongs to those 7 diatomic molecules. Remember that Hunkel brief? That was the mnemonic we learned in class. So hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, fluorine. Whenever they're by themselves, you always have to show them as diatomic molecules when you're writing the equations, because that is the more stable form. Okay. Here is another one. Aqueous zinc chloride and hydrogen gas forms when zinc metal reacts with solution of hydrogen. When zinc metal reacts with solution of hydrogen chloride. So once again, we have to figure out what are the reactants and what are the products. So reactants you're going to write on the left side, products on the right side. I already have an arrow here. It says zinc chloride and hydrogen gas is formed. So zinc chloride, yes, you do have to have a prior knowledge of writing formulas, guys. So it says aqueous, so I'm going to write AQ, and it says hydrogen gas. So hydrogen is diatomic molecule, you write 2 at the bottom. This is, the formula is Zn2 plus and Cl minus, you crisscross, that is how you get ZnCl2. reacts with solution of hydrogen chloride. So what is reacting with solution of hydrogen chloride is zinc metal, meaning it is solid since it says metal, and hydrogen chloride or hydrochloric acid, since it says solution, so you're going to write AQ again. That is the chemical equation. Solutions of potassium iodide and lead nitrate reacts. So these are our reactant from here to here. Potassium iodide is Ki and it says solution, so I'm going to put AQ in parentheses, and then it says lead nitrate. Lead nitrate is the reactant as well. How did I get that? Because Pb is 2 plus, NO3 is minus, you do the crisscross, that is how you get that formula. And you're going to write AQ again since it is a solution. They both are solutions. To produce a solution of potassium nitrate, so potassium nitrate is a solution, you again write AQ in parentheses, and it is producing solid lead nitrate, which is PbI2 solid. How am I getting this one? K plus KNO3 minus, you cancel the charges because they are equal and opposite. PbI2, that you're getting Pb2 plus, and I minus, you crisscross, that is how you get PbI2. Okay, so our reactants and our products, first we identify from the word equation. Now let's do opposite. How about this one here? So let's say you have to write down the word equation. So the word equation is, you can look at the periodic table, and again you need to know the what do these symbols stand for, or what do these formulas, how do you name them. Here you have a magnesium which is solid, so you're going to say magnesium metal. So you have a magnesium metal, all right, reacting with, because this plus sign means reacting with what? So magnesium metal reacting with oxygen gas. And when solid magnesium, or when magnesium metal reacts with oxygen gas, it yields means an arrow. What is it yielding? Magnesium, solid magnesium oxide. So magnesium metal reacts with oxygen gas to yield solid magnesium oxide. Now look at this one here. You have a sign of symbol of heat, and also you have this substance here. This is a catalyst. So what are we doing here is you are heating potassium chlorate. Again, you need to have a prior knowledge of naming the compounds. This is potassium chlorate. So when potassium chlorate is heated in the presence of catalyst, and what is our catalyst? MnO2. So this is our catalyst, all right? Catalyst speeds up the reaction. It decomposes. Decomposes means break down. So this potassium chlorate is breaking down when the catalyst manganese dioxide is used and this reactant is heated. It decomposes into solid potassium chloride. So decomposes into solid potassium chloride and oxygen gas. All right. Or you can also say it yields. All right. You could also say it yields, YIELDS. It yields to produce solid potassium chloride and oxygen gas. Either one is fine, but this is a decomposition reaction. The bigger substance is breaking into smaller substances. That is why we can write it as decomposes. Okay. Now let's look at this reaction here. What can you tell from this reaction? There are so many things you can tell from this reaction. Why do we actually even write a reaction? So from here you can tell how many substances are we using, correct? You can tell we are using water with one substance, another one is hydrogen 2, and then oxygen 3. So what can we tell? We are using 3 substances. What else we can tell? We can tell what is the formula of those substances. We can also tell what is the physical state of those substances, like liquid, gas, gas. That's the physical state. So you can tell what are your reactants, what are your products from here, right? If you have an equation which is actually completely written, all right, and correctly written, completely written and correctly written equation can tell us what are your reactants, what are your products. They will also tell you what are the formula of substances, right? Like what is the formula of these substances? How many substances are here? How many substances? You can tell that as well. 1, 2, 3. 3 substances total. They can also tell you the number of atoms. They can also tell you the number of molecules. So here you have one substance here, another substance here, another substance here. So this one is the molecule, and this equation is not balanced. If it was balanced, you would have 2 here and then you would have 2 here. So let me bring this now so that here, let's have everything here. This is actually explaining. Let me have this right here because we haven't talked about balancing equation. I don't want to talk about this. So just need to understand, if you have a complete and correctly written equation, you can tell what are the reactants. You can tell how many substances are there. Like right here on the reactant side, you have water, that is one substance, and here you have hydrogen and oxygen, 2 substances on the right side, and how many of each one them. And what's the formula here? What are the physical states? Liquid, gases here. How many molecules? So this one here, this number in the front, it is telling you how many molecules. Here no number, it means 1. 2 molecules of water, 2 molecules of hydrogen, 1 molecule of oxygen. How many atoms are here? 2 times 2, 4. 2 times 1, 2. This one 2 times 2, 4, and this is 2. Okay, so here are the number of atoms, and it also tells you the amount of the substance. You can tell all those things from the completely written equation. So guys, I want you to try this one here. Write down the word equation. So just pause it and match up your answer here. Is this what? Here, pause. All right. So is this what you wrote? That these solutions of potassium bromide reacts with solution of silver nitrate to yield the solution of silver bromide and the solid silver bromide and the solution of potassium nitrate. If this is what you wrote, that means you're getting it. So let me tell once again, you're reacting solution of potassium bromide with silver nitrate to yield solution of potassium nitrate and the precipitate of silver bromide. This is the solid. Insoluble solid is called precipitate. Here, aluminum oxide is decomposed, meaning this substance is going to break apart to produce solid aluminum and oxygen gas. This one, calcium, solid calcium reacts with oxygen gas to yield calcium oxide. So one last thing I want you to do is try this yourself. Check for understanding. It's like a closer. And if there is any struggle with any of the answers, then please rewatch the video. Thank you. Hope it was helpful. We are going to do more practice later.